Are the boundaries of the five great oceans defined solely by geography? Or were other factors, such as water properties and flow patterns, also considered when determining them? Ocean water's distinct physical and chemical properties make their meeting points visible, especially where the Atlantic and Pacific Oceans converge. If you've ever seen images of these two oceans meeting, you may have noticed that their waters appear separated by an invisible wall. But why does this happen? Water from the Atlantic and Pacific Oceans differs in several ways, particularly in salinity, density, and temperature. These differences create a boundary known as a halocline, which slows down the mixing process. At their meeting point, you can see a clear contrast in watercolor and composition due to these physical differences. The separation is caused by more than just the fact that they belong to different oceans. The variations in salinity and density are responsible for keeping the waters apart for long periods. When water has a higher salt concentration, it also has a higher density, making it heavier than water with lower salinity. Now, if that's the case, why don't we see one ocean sinking beneath the other? According to the laws of physics, denser substances sink while lighter ones rise. Shouldn't the water with higher salinity be at the bottom and the lighter water remains at the surface? The reason this does not happen is that the difference in density between the two oceans is not extreme enough to create a complete separation. Instead of sinking, the waters remain adjacent but unmixed for long periods due to their distinct properties. Another important factor affecting this separation is ocean currents. The movement of ocean water is influenced by the Coriolis effect, which causes currents to curve differently in each hemisphere. In the northern hemisphere, ocean currents move in a clockwise direction, while in the southern hemisphere they move counterclockwise. This phenomenon further prevents immediate mixing between the two oceans. Additionally, the strength of molecular bonding between water molecules plays a crucial role. Due to differences in water properties, the bonding forces between molecules in each ocean are not identical, making their fusion much slower than expected. However, while it may seem like the Atlantic and Pacific never mix, the truth is, they do, but at an extremely slow rate. Over time, the waters gradually blend, though this process is nearly imperceptible on a human timescale. This incredible natural phenomenon highlights the complex and dynamic nature of our planet's oceans. Want to learn more fascinating science facts? Subscribe to the Science Sphere. Don't forget to like, share, and follow for more amazing science content.